All right, let's dive in. Today, we're going to pull back the curtain and look at how computer programs actually talk to us. By the end of this, you're going to have all the basic tools you need to build your own simple, interactive programs, ones that can ask questions, listen to what you say, and then talk back. So let's get right to it. I mean, really think about it for a second. Every time you use an app, a game, or even just a login screen, the program is asking you for something, right? It needs your name, your password, your next move. It needs to listen. So how do we actually build that bridge between us and the code? Well, that's the journey we're about to start. Okay, so first things first. Before our program can do anything cool, we have to teach it how to listen. We need a way to literally pause everything and just get some information straight from the person sitting at the keyboard. And for that, our go-to tool is the input function. Think of this function as the program's ears. It's super simple. First, it shows the user a prompt. That's just our question, like, what's your name? Then it just waits. It patiently waits for you to type something and hit enter. And whatever you typed gets captured and stored in a variable so we can use it later. So let's see this in action. It's way easier than it sounds. We'll build a little greeter. On line 1, we ask for a first name, and whatever the user types, we'll store it in a variable called first_name. Then, on line 2, we do the exact same thing for the last name. Finally, on line 3, we use print to say hello and then add the first and last name we just got. Easy, right? And here's what happens when you run it. The program asks for the first name, the user types Vinny. It asks for the last name, they type Brown. And boom, the program spits back a personalized message. Hello, Vinny Brown. Just like that, we've had a real back-and-forth conversation with our code. Okay, so that was awesome for names, which are just text. But what if we need a number? Like someone's age or the price of an item. This brings us to our first little puzzle on this journey. And here's the catch. This is a really important one. The input function always gives you back text. I mean, always. Even if the user types the number 25, the program doesn't see the value 25. It sees the text characters 2 and 5. And you can't do math with text. It's like trying to add the letter A to the letter B. It just doesn't work. So how do we fix this? Well, we use these handy little translator functions. We've got int, which takes text and converts it into an integer. That's just a whole number. And then we have float, which converts text into a floating point number. That's just a fancy way of saying a number that has a decimal point. Now here's a common trick to make your code a little cleaner. Instead of getting the input on one line and converting it on the next, you can just do it all at once. You just wrap the input function right inside the translator function. So here we ask for the age, and whatever text we get back is immediately turned into an integer. Same thing for income, but we're using float since income might have decimals. All right, so now that we can actually get numbers from our user, we can finally unlock the real powerhouse of our program, doing math. It's time to pop the hood and get into the engine room. So here is your basic math toolkit. Plus, minus, multiply, and divide. They all work pretty much exactly how you'd expect. But then we have a few special ones. The double star is for exponents, to the power of. The percent sign gives you the remainder after a division, which is surprisingly useful. And the double slash gives you the result of a division, but chops off the decimal part. Now, hold on. Before you start plugging in numbers, there is one critical rule you absolutely have to remember. Just like back in math class, the computer follows a very strict order of operations. It doesn't just go from left to right. This is called operator precedence, and it's super important. And here's that order. It's probably going to look pretty familiar. First up, anything in parentheses gets solved. Then it handles any exponents. After that comes all the multiplication and division stuff. And dead last, it does the addition and subtraction. Getting this order right is the key to making sure your program isn't giving you wild, incorrect answers. So we figured out how to get input and how to process it. For our last step, let's talk about the output. Because it's not just about what your program says, it's also about how it says it. Let's learn how to polish up our program's responses to make them look clean and professional. So you know how every time you use print, it automatically starts a new line afterward? Well, you can actually change that. If you add this little argument, end equals space, you're telling the program, hey, instead of a new line, just end with a space. That lets your next print statement pick up right on the same line. And it's a similar deal when you're printing a bunch of different things at once. By default, print sticks a space between each item. but you can change that separator or sep to anything you want. So instead of a space, you could use an asterisk, a dash, anything. It gives you a ton of control. Okay, now for the really cool stuff. These are called escape characters, and they're like little secret codes you can tuck inside your text to control the layout. The ones you'll use all the time are \n for a new line and \t to add a nice clean tab. You can even use them to print out characters like quotation marks that would normally confuse the code. And this example right here just shows how powerful they are. Check out this single line of code. We use an N to jump to a new line for our list, and then we use another N and a T before each item, and look at the output. We get a perfectly formatted multi-line list all from just one simple command. How cool is that? And that's pretty much it. Those are the absolute fundamentals for making a program that can interact with a human. You now know how to make your program listen using input, how to make it think using math, and how to make it talk back clearly using print. So you've got the tools. The only question left is, what are you going to build first?